Alright, so in this video, we're gonna find the constant of integration. This is gonna be about finding the constant of integration. And to find the constant of integration, let's just quickly recall something. So whenever we integrated a function, f of x, with respect to dx, what we got was a function capital F of x plus some constant c. And this is the c that we are going to be looking for. Now this, the right-hand side, has the following property. If you differentiate f of x plus c, then you get small f of x plus 0, right? Which is just f of x. So basically, your function f of x should have the property that if you differentiate it, you should get small f of x, right? That is what we have discussed from the previous video. That is the result that we got from the fundamental theorem of calculus, that integration and differentiation are reverse processes. Now, using the idea, if we integrate f dash of x, right? If you integrate the first derivative, then you should get your main function, f of x plus c, right? And that is what we are doing in this video. We are integrating the first derivative, and we are going to get the main function. And the main function has the property, the main function f of x has the property that if you differentiate it plus c, the derivative is just 0, right? You get f dash of x. So this is what we are going to do. So we are going to look for f of x plus c, and we are going to be given a condition, maybe a few conditions, depending on how many systems they want us to solve. But we are going to look for c, or any other variable that they ask for. And how we are going to do it? We are going to substitute this value. And things will be clearer when we do actual examples. So let us begin with question 1. And for question 1, I'll just do b, d, and f. I'll leave A, C, and E for you, and then we'll work on other questions as well. And I'll do B very slowly so that you can see all the steps, and then I'll sort of speed up as I go on. So I hope that is okay. So question B says dy by dx, which I can write as is equal to 2x, 3x minus 1, and we are given the point minus 1 comma 2. All right. So remember, your dy by dx is just f dash of x. And that is given. Now let's multiply this out. 2 times 3, 6. X times x is x squared. Right? And then I have minus 2x. All right. So now if I integrate this side, right? If I integrate this, then I will get f of x plus c. If I integrate. So remember, integration of f dash of x dx should be equal to f of x plus c. Do not forget your constant of integration. So now let's integrate this, which is this expression, right? So 6x squared minus 2x dx. So now remember the rules of integration. I can write it as the integral of 6x squared dx, and then I copy my middle sign, so minus integration of 2x dx. And I can factor out all the constants. So I can integrate just x squared dx minus I can integrate x dx. Now the golden rule that we discussed was that the integral of x to the power n dx was x to the power n plus 1 divided by n plus 1 plus c. That means, and this is for n not equal to negative 1. N not equal to negative 1. So this is the rule that we are going to be using. Here, n is 2. Here, n is 1. Right? So now, using this formula, apply it here. We have 6. Dot means multiply here. X. So if n is 2, 2 plus 1, that gives me 3. And I have to divide by n plus 1. 2 plus 1 is 3 again. And so you can write plus c1 here, right? minus, you have x to the power 1. So x, 1 plus 1, so n is 1 here, right? So 1 plus 1 gives me 2, divided by 2 plus c2. All right, so now that we have that down, you can combine constants together, c1 and c2. You combine them together, you get your final constant, just c, right? Sorry, you have a 2 here. So you are going to have 2 times x squared divided by 2. So I forgot to factor out the 2 here. All right, so now that we have this, 6 divided by 3, that is 2x cubed minus 2 divided by 2 cancels out. You get x squared plus c1 plus c2. We'll just call that a constant c. And remember, this is f of x plus c. That is the integration of f dash of x dx, right? So now, we'll just call our main function is equal to this, f of x plus c. All right, so now we need to know what is this constant, right? So let's just say that the function we were looking for has this expression. Now we are given this point, minus 1 comma 2. So now we know that if x is minus 1, so you substitute minus 1 here, you should get 2. So you substitute negative 1 into this expression. So you get 2 times minus 1 cubed minus minus 1 squared plus c should be equal to 2, right? So this gives you negative 2 minus 1 plus c is equal to 2. And if you simplify everything, you get c is equal to 5. So the function, so the question has asked find the equation of the curve. So your equation is going to be 2x cubed minus x squared plus 5. So you just want to write whatever value of c you got, you just want to substitute here. And that is going to be your equation. You can write it as f of x is equal to that, or you can just write the equation of the curve, or you can write y is equal to however way you prefer it. So you can write y is equal to this. So because it says as an equation, usually they would prefer you to write it like this way. If they ask you to find the function, it's going to be f of x is equal to 2x cubed minus x squared plus 5. Let me make sure if my mic is recording. Okay, it is. All right, so that is going to be the solution for part B, 2x cubed minus x squared plus 5. All right, so we are done with B. Let's do D. And now I'm going to be a bit quicker here. So D is dy by dx is equal to 2x cubed minus 6 divided by x squared. And 3 comma 7 is a point. All right. So now let's just simplify this expression. I can write it as 2x cubed divided by x squared minus 6 over x squared. And this can be further simplified as 2x minus 6x to the power negative 2, right? And I hope this simplification is clear. Now, f of x, the main function or the main equation we are looking for, is just going to be the integration of this expression as we saw in the previous example, right? It's just going to be the integral of the first derivative. And when we start integrating this, here's what we get. So you get integral of 2x dx minus integral of 6x to the power negative 2 dx. So you can factor out your numbers. So you have x to the power 1 minus, you can factor out your 6. So you have integral of x to the power negative 2 dx. So now, when you integrate this, you raise the power by 1. So your power is 1. You increase it by 1, you get 2, divided by your new power. And it's the same here. You raise your power by 1. Negative 2 plus 1 is negative 1. You divide by your new power. And do not forget plus c. That is the most important part. So 2 and 2 will cancel out. So you get x squared. You have minus and 2 negative signs. It will actually give you a plus 6 over x, right? X to the power negative 1, it will go down. So you have 6 over x plus c. And now you can substitute your point. Your point was 3 comma 7. So basically that means that f of 3 is going to give you 7. So you put 3 into this equation. So 3 squared plus 6 over 3 plus c is going to be 7. So that is 9 plus 3 is plus c. Sorry, 9 plus 2 plus c is going to be 7, right? And that is going to be c is equal to 7 minus 11, and that is going to be negative 4. And finally, the equation that we were looking for, so you can write y is equal to x squared plus 6 over x minus 4. And that is it. That is going to be the solution that you were looking for. Plus 6 over x minus 4. All right. So we are done. Part F. We have dy by dx is equal to 1 minus square root of x squared divided by square root of x. And then we have the point 9 comma 5, I think. Yeah, 9 comma 5. All right. So now let's simplify the numerator first. So now if you do this, right? 1 minus square root of x times 1 minus square root of x. That is 1 minus square root of x squared. 1 times 1, that gives you 1. 1 times negative square root of x is negative square root of x. Negative square root of x times 1 is negative square root of x. And negative square root of x times negative square root of x is going to be positive square root of x squared, right? And if you simplify that, then you're just going to get x. So you're going to get 1 minus 2 square root of x plus x. So let me write that here. 1 minus 2 square root of x plus x divided by square root of x. Now let's simplify. I can write this as 1 over square root of x minus 2 square root of x divided by square root of x plus x over square root of x. And if you simplify this further, you're going to get x to the power negative half minus square root of x and square root of x cancel out, 2, plus, and if you simplify this, right, it's going to be x to the power 1, and you have x to the power half in the denominator. So it's going to be x to the power 1 minus x to the power, it's going to be, so you subtract the powers, right? So you are going to get half here. So now that we know what dy by dx is, f of x is going to be the integral of this expression. So you do x to the power negative half minus 2 plus x to the power half dx. So now let's integrate this. When you integrate, we'll do it separately. Right? And now, because the power is not negative 1, so you can factor out your 2 here and write it as x to the power 0. And we know how to work with this because we have a formula, right? X to the power 0 is just 1. So 1 times dx is just going to give you dx. So it doesn't matter. So now you raise your power by 1. Negative half plus 1 is going to give you positive half. And then you divide by your new power. All right. You raise your power by 1, right? You had 0. And then you divide by your new power. You raise your power by 1. So half plus 1 is going to give you 3 by 2. And then you divide by your new power. And when you simplify everything, you are going to get 2x to the power half minus 2x plus 2 over 3, x to the power 3 over 2. And do not forget your constant of integration. So now, we need to substitute the point 9 comma 5. So if x is equal to 9, then your output is 5, right? So just substitute 9 here. So 2, 9 to the power half, which just means square root of 9, minus 2 times 9 plus 2 over 3. What does x to the power 3 over 2 mean? Well, that just means x to the power half, and then you raise it to 3, right? So 9 to the power half, you raise it to 3, plus c equals to 5. So this is just 2 times square root of 9 is 3 minus 18 plus, if you simplify this, you're going to get 27, right? And 27 divided by 3 here, if you simplify this, you are going to get 2 times 9. And 9 times 2 is going to give you 18, and this is going to cancel out. So you're solving for this equation. So c is just going to be 5 minus 2 times 3 is 6, right? If you take it to the other side. So c is going to be negative 1. And therefore, your equation is going to be this, right? So 2x to the power half is square root of x minus 2x plus 2 over 3 x to the power 3 over 2 minus 1, right? That was what c, the value of c that we got. So that is going to be the equation of your curve. And let me just check it for you. 2 square root of x minus 2x plus 2 over 3 x to the power 3 over 2 minus 1. Yes. This is your solution for part F. And we are done. So moving on to question 2. A curve is such that we are given this equation, right? dy by dx is equal to negative k over x squared, where k is a constant. Given that the curve passes through the points, so the curve passes through, so, okay, let me just write 6 comma 2.5 and negative 3 comma 1. So we are asked to find the equation of the curve. Now, do not substitute these points here, because this is the first derivative. It's not the curve. So first of all, we need to integrate it. But before I do so, because I see decimal points here, I'm going to go get my calculator. So I'm going to pause the video for 10-20 seconds. All right. So now we know how to find the equation of the curve from the previous first question, right? So now, if you're wondering, in the previous question, you were only given 1 point. Why do we need 2 points in this case? Well, we are given 2 points because we have one unknown here. We are going to have another unknown c. So you need 2 equations to solve for 2 unknowns. So that is why. All right. So it just says find the equation of the curve. So actually we need k and c, right? All right. So now we need to find f of x. And that is going to be the integral of this expression, right? With respect to dx. And now remember, k is a constant. So you can factor out minus the negative sign and the k and just integrate this expression. So you have minus k times integral of x to the power negative 2 dx. And if you integrate it, you get x to the power negative 1. You increase the power by 1. You divide by your new power and you add your constant of integration. So now the negative signs will cancel out and you get k over x plus c if you simplify. So that is the curve that you have for now. And now let's substitute in our point. So if x is 6, f of 6 gives you 2.5. So you substitute 6 here, so you know that k over 6 plus c is equal to 5 over 2. 2.5 is 5 over 2. That is equation 1. And the second point is that f of negative 3 is equal to 1. And basically, that gives you k divided by negative 3, right? Plus c is equal to 1. And now we can simplify this further. And I'm going to pause again because there's music coming from outside. So I'm going to go to a quieter room. I hope that is okay. All right, I don't think the music's gone, but my voice is going to be louder anyways. Okay, so now this is equation 2. So now let's simplify and solve the 2 equations. So if I multiply by 2 on both sides here, right? Because I don't want 2 in my denominator. And I think you have learned enough methods to know how to solve this. But if I multiply by 2 on both sides here, I am going to get... Okay, let's multiply by 6 actually. I don't want 6 here because that's bigger, right? So I multiply by 6 on both sides. I'm going to get k because 6 and 6 here are going to cancel out. Plus 6 times c is equal to 6 times 5 over 2. And 6 by 2 is going to be 3. So you're going to get 15. So that is equation 1. And now I'm going to multiply by negative 3 on both sides. So I'm going to get k minus 3c is equal to negative 3. So I have k minus 3c is equal to negative 3. That is my two equations. If I subtract the two equations, k minus k cancels out. 6c minus of minus 3c, that is going to be 9c. 15 minus of minus 3 is going to give me 18. So c, I know, is going to be 2. And now I can just substitute this here. So k minus 3 times 2 is going to be negative 3. So k minus 6 is negative 3. K is positive 3. And now I can write my equation. The curve is going to be y is equal to k is 3 over x, and c is 2 plus 2. And that is it. 3 over x plus 2 is going to be the equation of your curve. And we are done with question 2. And most of the questions that we are going to do is just going to be the same, actually. All right. So question 3 is exactly, you do it in the same way. So you are given this expression, right? So I'm going to do it very quickly. dy by dx is kx squared minus 12x plus 5. And I hope you can follow. Passes through the points 1 comma negative 3, 3 comma 11. And I hope you're familiar with solving systems of linear equations, because I'm going to do that quickly as well. So find the equations of the curve. All right. So f of x is just going to be the integral of kx squared minus 12x plus 5, right? With respect to dx. So if I integrate this, you're going to have this integral. If you solve for the integral, you're going to get this expression. So I'll leave for you to try to do the integration on your own here. And now we're just going to substitute the points in. So f of 1 is given to be negative 3. So just substitute 1 in. And you're going to get k over 3 minus, so if I substitute 1 here, I'm going to get k over 3 minus 6. If I substitute 1 here, I'm going to get plus 5 plus c is equal to negative 3. So let's simplify this. Minus 6 plus 5, that is minus 1. If I add minus 1 on both sides, so if I take this here, I'm going to get negative 2. Now I need to multiply by 3 on both sides. So I'm going to get k. So if I multiply by 3 on this side, right? This will cancel out, but I need to multiply here as well. So I get 3c. And then if I multiply 3 here, I'm going to get negative 6. So that is going to be the first equation. And I also have f of 3 is going to be 11. So substitute 3 here. So k times 3 cubed is 27 divided by 3. And 27 divided by 3 times k, that is just 9k, minus 6 times 9, right? 3 squared is 9. So 6, 9, that is 54. Plus 5 3s are 15, plus c is 11. 9k minus, so, all right, so negative 54, right? It's negative 54 plus 15. That gives you negative 39 is equal to 11. Now, if I add negative 39 on both sides, I get 9k plus c is equal to 50. And I know that k plus 3c is equal to negative 6. So now, if I multiply by, so you can choose whether you want to multiply, you can choose however method you like to solve these two equations, but I am going to multiply my second equation by 9. All right, so I know that my first equation is 9k plus c, or the top equation, which was equation 2 actually, but it's 9k plus c is 50. And if I multiply my first equation, equation 1 by 9, I am going to get 9k plus 27c is equal to negative 54. And I'm going to subtract these two. Why? 9k minus 9k cancels out. C minus negative 27c, that is negative 26c, is equal to 104, right? And 104 divided by negative 26, that is just gives you c is equal to negative 4. If you solve this, you get c is equal to negative 4. And now you can substitute this here. 9k plus c is 50. So c was just -4, right? So 9k is 54. Because if you add 4 on both sides, you get this expression. And k is just going to be 6. So finally, you can go here and you can write your equation. Y is equal to k is just 6. 6 divided by 3, you're going to get 2, right? Here, 6 divided by 3 is going to give you 2x cubed minus 6x squared plus 5x, and c was -4. And that is going to be your solution. All right. And we are done with question 3. Question 4 is a bit different, but we're going to solve it probably in the same way. A curve is given, we are given again, k is a constant, given that the curve passes through the point. All right, so this is interesting, right? So given that the curve, so let's just write it down. dy by dx is equal to kx squared minus 6. And instead of writing it like this, I'm going to write it as 6x to the power -3. And k is a constant. Given that the curve passes through the point 1, 6, right? It passes through 1, 6 on the curve, and that the gradient of the curve at P is 9. Remember, dy by dx at a particular value of x gives us the gradient. So I can solve dy by dx at the point P. Point P, the x coordinate is 1. At x is equal to 1 is given to be 9. So substitute 1 into dy by dx. So I'm going to get k minus 6 times 1 to the power -3 is equal to 9. And 1 to the power -3 is just 1. So k minus 6 is 9. And k, you have solved it immediately, is 15. And now we just need to use this point to find c. All right, so we can just substitute k here. So I know dy by dx is just 15x squared minus 6x to the power -3. F of x is going to be the integral of this expression. All right, so now you can write it as 15x squared dx minus 6x to the power -3 dx. And when you simplify, you are going to get 15 times, if you integrate x squared dx, that is going to be x cubed by 3, right? Integration of x squared 3. You increase the power by 1, so 2 becomes 3, and then you divide by your new power. And you have 6 times, if you integrate x to the power -3 dx, you're going to get x to the power -2. -3 plus 1 is -2. You divide by -2, and then you add plus c. That is the important part. So 15 divided by 3, 5x cubed. 6 divided by -2 is -3. Minus of minus will give you a plus sign. So you have this expression. And that is going to be f of x. So now you're given this point lies on the curve. So if you substitute f of 1, you're getting 6. So substitute 1 here, you get 5. Substitute 1 here, you get 3. Plus c is equal to 6. So 8 plus c is equal to 6. C is equal to -2. And when you substitute -2 into here, you get the equation of your curve. So y is equal to 5x cubed plus 3 over x squared minus 2. That is your solution. All right. And now we are just reviewing some of the questions that we previously did. So this is a tangents and normal question, right? So curve has this equation. Given that the curve passes through, so let me just write it down. We are given dy by dx is equal to 5x times square root of x. So this is just x times x to the power half. X to the power 1 times x to the power half, which you can write it as x plus half. And if you simplify everything, you're going to get 3 over 2 plus 2. And the curve passes through the point 1, 3. So find the equation of the curve. Standard procedure, right? F of x is the integral of 5x to the power 3 over 2 plus 2 dx. Just integrate dy by dx is the idea. So 5 integral, so I can write this as 5x to the power 3 over 2 dx plus integral of 2 dx, right? And this is going to be 5 dx plus 2 integral of x to the power 0 dx, which is just 1. And you can just remember, if you just have integral of dx, right? Or if you have integral of some constant dx, then you're going to get c times the constant, whatever constant you have, times x. So if it's k, then you're going to get kx. So we have 2 here. When you integrate it, you're going to get 2x. So 5. If you raise your power by 1, 3 over 2 plus 1 is going to give you 5 over 2. And when you divide by your new power, which is 5 over 2, this fraction is actually going to flip over, and we will see that. But let's just write this as 2x plus c. All right, so you have 5. If you simplify this, you're going to get 2 over 5x to the power 5 over 2 plus 2x plus c, because this fraction is going to flip over, and this cancels out. So you're going to get 2x to the power 5 over 2 plus 2x plus c. And we are given a point, 1, 3. So f of 1 is equal to 3. So substitute 1 here. 1 to the power 5 over 2, it's still 1. So you get 2, plus you substitute 2 here, you get 2. Then you substitute 1 here, you get 2, plus c is equal to 3. And c, you will get -1. So the equation of the curve is going to be 2x to the power 5 over 2 plus 2x minus 1. That is the equation of the curve. And the textbook prefers to write this as x squared times square root of x. And you can check why. 5 over 2 is going to be 2 plus half. All right. So now that we have this down, plus 2x minus 1. So this and this expression is the same thing. So now we have the equation of the curve down. And it says the equation of the tangent to the curve when x is equal to 4. All right. So equation of the tangent to the curve. Well, we can find the gradient, right? So we know how to do that. We have discussed it at length. So I'm going to do it very quickly. So just evaluate dy by dx when x is equal to 4. So that is just going to be substituting 4 into this equation. So 5 times 4 times square root of 4 plus 2. And that is going to be 5 4s are 20 times square root of 4 is 2 plus 2. And that is going to give you 42. The equation of the tangent to the curve when x is equal to 4. So when x is equal to 4, what is my y value? What is my output value, right? So we need to use this equation to figure that out. All right. So when x is equal to 4, what is y equal to? Do not look at the derivative. Look at the main curve, right? So when x is equal to 4, then your y is going to be 4 squared times square root of 4 plus 2 times 4 minus 1. So I've just substituted x is equal to 4 here. And if you simplify, you get 32 times 2. If you solve, 2 times 4 squared is 16, so 2 times 16 is 32, square root of 4 is 2. So 32 times 2 plus this is going to be 8 minus 1. So 64 plus 8 minus 1. 64 plus 8 is 72 plus, 64 plus 8 is 72 minus 1 is 71. So y is equal to 71. So therefore, your equation is going to be y minus y0, slope of the tangent, right? It says the tangent line, x minus x0, which are the arbitrary points, or x minus x1, if you prefer the subscript 1, is also fine. So y minus 71, slope of the tangent we found to be 42, x minus 4, because we used x is equal to 4. So y minus 71 is equal to 42x minus 168, I believe. And finally, y is going to be 42x minus 168 plus 71. And that gives me, so negative 168 plus 71, negative 97. So your equation is 42x minus 97. And we are done with question 5. So it's just a review of the topics that we already discussed for chapter 5 when we were discussing tangents and normals and applications of the first derivative. All right. So we are done. Question 6. A curve is such that this is given, right? Routine. dy by dx is given to be kx plus 3. The gradient of the normal, right? The gradient of the normal to the curve at the point 1 comma negative 2 is this. Well, dy by dx gives me the gradient of the tangent, not the normal, right? So we know that m times the gradient of the normal times the gradient of the tangent, they are perpendicular to each other, right? So their product of their gradients must be negative 1. So we know that the gradient of the normal is negative 1 over 7 times the gradient of the tangent is negative 1. So now negative negative cancels out and you will get the slope of the tangent is just positive 7. And once you do this, question 6 just becomes question 5. So slope of the tangent is equal to 7 at this point. So dy by dx at what point? It's just 1 comma negative 2. When x is equal to 1, it's just equal to 7, right? mt is 7. So we work with tangents with the first derivative, not the normal. So just substitute 1 into this expression. And you get k plus 3 is equal to 7. And k is just going to be positive 4. So you know that dy by dx is equal to 4x plus 3. So f of x is going to be the integral of 4x plus 3 with respect to dx. So that is going to be the integral of 4x dx plus the integral of 3 dx. And I'm going to leave the integration to you, but you will see that you should be getting 2x squared plus 3x plus c. That is the integral. All right. And now that we have the integral, we are also given a point, 1 comma negative 2. So f of 1 is equal to negative 2. So substitute 1 here. You get 2 plus 3 plus c is going to be negative 2. So c plus 5 is equal to negative 2, and c is equal to negative 7. So we are done. The equation of the curve, y, is going to be this expression, right? 2x squared plus 3x minus 7. And we are done. All right, question 7. I think is pretty much the same question, right? A curve is such that dy by dx is given to be 3x squared plus x minus 10. We are given this, so we can find the equation of the curve, right? So point is 2 comma negative 7. So I'm going to go through this a bit quicker. So f of x is going to be the integral of 3x squared plus x minus 10 with respect to dx, which is just integral of 3x squared dx plus the integral of x dx minus the integral of 10 dx. And if you simplify this, you are going to get 3 times x cubed divided by 3 plus x squared divided by 2 minus 10x plus c. Do not forget, indefinite integral. If there are no values on the bottom and the top of your integration sign, always add a plus c. This cancels out, so you get x cubed plus half x squared minus 10x plus c. That is your f of x. And now we can substitute this point. F of 2 is equal to negative 7. So substitute 2 here. So if you substitute 2 cubed, it's going to be 8 plus 2 squared is 4. 4 divided by 2 is going to give you 2. minus 20 plus c is equal to negative 7. So this is 10 minus 20 is negative 10 plus c is negative 7. So c is going to be 3. And now the equation of the curve is just y is equal to x cubed plus half x squared minus 10x plus 3. Now, it says the set of values of x for which the gradient of the curve is positive. The gradient is positive if dy by dx is greater than 0. So they just ask you to solve for 3x squared plus x minus 10 bigger than 0. So let's try to factorize this. The sum has to be positive 1. The product has to be equal to 3 times negative 10, negative 30. So my numbers are going to be positive 6 and negative 5. Add them together, I get positive 1. Multiply them together, I get negative 30. So I can write my middle term as plus 6x minus 5x minus 10 bigger than 0, right? Remember, if I simplify this, I get plus x. Now from these two terms, I can factor out a 3x, and I get x plus 2, right? And if I factor out if I want x plus 2 from my second term, 2 terms as well, I need to factor out a negative 5, right? So now I can factor out x plus 2 and 3x minus 5. So now we just use a regular number line method. So if you set this to be 0, 3x minus 5 is equal to 0, x is equal to 5 over 3. That is what you are going to get. This is positive. This is 1 point, I believe, 5 over 3 is 1.66667, right? 67, but okay, 5 over 3. And if you set this equal to 0, you are going to get negative 2. Now think of a number, so which is approximately 1.66667, right? So put in a number bigger than this, which is 2. Put in 2. If you substitute 2 here, you get 3 times 2 is 6. 6 minus 5 is 1. So this is positive. You substitute 2 here, 2 plus 2 is 4, which is positive. So positive times positive, it's positive here. Substitute a number between negative 2 and 5 over 3. 0, right? You substitute 0 here, you get this is positive. You substitute 0 here, you get something negative. So it's going to be negative between negative 2 and 5 over 3. Now substitute a number less than negative 2. Say negative 3. Negative 3 plus 2 is going to be negative 1, which is negative. Negative 3 times 3 is negative 9. Minus 5 is negative 14, which is still negative. Negative times negative is positive. All right, so now that we have this down, now we know that, and remember, x cannot be equal to negative 2. If it is, then it's 0, right? And if it's equal to 5 over 3, then it's 0. So now the gradient is positive. dy by dx is bigger than 0 if x is less than negative 2, because it's to the left, right? Less than negative 2. This is a number line. That's why it's less than negative 2. Or x is bigger than 5 over 3. So that is going to be your solution. So x is less than negative 2 or x is bigger than 5 over 3. So that is your solution. 5 over 3, you can write it as 1 over 3. No, 1 2 over 3. Yeah. That is what the textbook gives you. But both answers are correct. And we are done with question 7. Question 8 gives us a second derivative. So basically, we discussed second derivatives, I believe, in chapter 5. So d squared y by dx squared, if you integrate this with respect to dx, you're going to get dy by dx plus c. So basically, if you integrate your second derivative, you are going to get your first derivative plus some constant. That is what you have to keep in mind. So the gradient of the curve at the point. So we are given the gradient, right? All right. So let's integrate this. Let's integrate 12x plus 12 with respect to dx. And remember, this is going to give me f dash of x, not f of x. Right? We are integrating our second derivative, so we need to get our first derivative. So the integration is not that complicated. It's very, very straightforward. So if you integrate this part, you're going to get 6x squared. If you integrate this part, you're going to get 12x plus c. That is f dash of x. Now, we are given at this point, the gradient is 10. So gradient just means dy by dx when x is equal to 0. So f dash of 0, which is dy by dx, that is equal to 10 when x is equal to 0. The gradient is equal to 10 when x is equal to 0. So substitute 0 here, and you will see that c is just going to be 10. So your first derivative, f dash of x, is given by 6x squared plus 12x plus 10. All right. So let's solve b first, because I've set up the question in a way that b becomes very easy to solve. But it says, show that the gradient of the curve, which is f dash of x, or dy by dx, is never less than 4. And to do so, we will complete the square. Or, yeah, that is, I believe, the easiest method. So let's factor out a 6. If you factor out a 6, you have x squared plus 2x plus 10 over 6, which is going to be 5 over 3. I just factor out a 6. And now, I can write this part, and please refer to the videos about completing the square. But I can write this as x plus 1 squared plus, so if you complete the square here, I believe you should get 2 over 3. That is what you should get when you complete the square. And you multiply everything in, you should get x plus 1, 6 times x plus 1 squared plus 6 divided by 3. This is 4, right? So now remember, go back to the stuff about transformations. This is a quadratic equation, right? If it's positive, it's concave up, right? That is concave up with vertex at -1, positive 4. Therefore, dy by dx bigger than or equal to 4. That is one way to reason this. Another way to reason this is, remember, when we talked about functions, we discussed that any square function, right, the function y squared is bigger than or equal to 0. So this part has to be bigger than or equal to 0, right? Whatever thing you square, doesn't matter, x plus 1, y plus 1, z plus 1, x plus 3, z minus 3, whatever. If you square it, it has to be bigger than or equal to 0 regardless of what x you put in. So if I multiply by 6 on both sides, using our ideas about inequalities, because 6 is positive, then we get 6 times x plus 1 squared also has to be bigger than or equal to 0, because 0 times 6 is 0. And now if I add 4, I get this equation. So if I add 4 on both sides, I get this inequality. And you see that this is dy by dx. dy by dx is bigger than or equal to 4. So you can reason that this is a quadratic equation that is concave up with vertex at -1, 4. So that means that dy by dx, the minimum point, is at going to be when y is equal to 4. Or you can reason through an inequality, whichever you feel is easier to understand, or you can calculate the minimum point of this concave up parabola and show that it is 4, so your parabola always has to be bigger than or equal to 4. So whichever method you prefer, but it's never less than 4. That means it's bigger than or equal to 4. So we are done with part B. Now part A asks us to express y in terms of x. So we have f dash of x here, and we solved for c, right? So we know f dash of x is 6x squared plus 12x plus 10. So we know f of x is just going to be the integration of this part. 6x squared plus 12x plus 10 with respect to dx. Now I'm going to skip over the integration. Feel free to try it on your own. But you're going to get 2x cubed plus 6x squared plus 10x plus c. And now we can substitute in this point because it's on the curve. So f of 0 is equal to 4. So substitute 0 here. And you will see that c has to be equal to 4. So your equation of the curve is 2x cubed plus 6x squared plus 10x plus 4. And we are done. Okay, I think these are the last two questions. All right, so I'm gonna go drink some water because my throat is very, very dry, and I'm gonna come back. All right, so question 9 says that we are given dy by dx is k plus x, where k is a constant. So given that the tangents to the curve at these 2 points, okay, are perpendicular. So basically, let's substitute 5 in here. When x is equal to 5, that is just 5 plus k, right? And dy by dx, when x is equal to 7, is just going to be 7 plus k. So these two tangent, so these are going to be the gradients of the two tangent lines, right? Because dy by dx is just gradient at a particular point. So at these 2 points, the tangent line is going to have these gradients. And if they are perpendicular, then the product of their slopes, their gradients, must be -1. So we know that 5 plus k times 7 plus k is equal to -1. So now if you simplify this out, you get 35 plus 12k, I believe. Yeah, 12k plus k squared is equal to -1. So k squared plus 12k plus 36 is equal to 0. So we are going to solve for this quadratic equation. If you solve, I think, if you complete the square, you are going to get this expression. You do get this expression if you complete the square. So I'll leave that step for you. But when you solve that, you're going to get this. So now, how did I immediately see that I get this? Well, k squared gives me k squared, right? 12k, well, 6 squared is 36, and 6 times 2 is going to give me 12, right? And that is what we were doing when we were expanding out. So that is a quick way of doing this, but I encourage you to do it the old-fashioned way. But you will get k is equal to -6. It has only one solution. So find the value of k, -6. We are done with that. And yeah. So also given that the curve passes through these points, find the equation of the curve. Okay. So we know that f dash of x, or dy by dx, is x minus 6. So f of x is just going to be the integral of x minus 6 dx. And if you integrate this, you're going to get half x squared minus 6x plus c. right? I'm doing things a bit quicker now. And passes through this point. So f of 10 is equal to negative 8, right? 10 comma negative 8, yeah. So substitute 10 here. You are going to get half. 10 squared is 100. Minus 6 times 10 is 60 plus c is negative 8. So this gives you 50 minus 60 is negative 10 plus c is negative 8. C is going to be positive 2. And now just substitute c here. So your equation of the curve is going to be half x squared minus 6x plus 2. And that is it. And we have reached the last question. A curve is such that dy by dx is 3 minus 2x, and this is a point on the curve. So find the equation of the curve. Very standard, right? So f of x is just going to be the integral of 3 minus 2x dx. I'm going to do the integration quickly. I will get 3x minus x squared plus c if you integrate it. And now I will substitute the point. So f of 1 is going to be 11. I'll leave you to do the integration on your own. So substitute 1 here. You get 3 minus 1 plus c is equal to 11. So c is just going to be positive 9. So y is 3x minus x squared plus 9. So we are done with part A. A line with the gradient this is a normal to the curve at this point. Find the equation of this normal. All right. So this is very straightforward, right? You're given the gradient, you're given the 2 points, so you just need to find the equation. So just use y minus y1 is m of normal x minus x1. And then y minus y1 is just 5. Slope of the normal is 1 over 5. X minus x1 is 4. Multiply by 5 on both sides. You get 5y minus 25 is x minus 4. And then you get 5y is equal to x. If you add 21 on both sides, you get plus 21. If you add 25 on both sides, right? If you send 25 here, you get this expression. And we are done with this topic. So the last question was very, very straightforward, actually. Do not overthink the second question because you're given everything that you need. You're given a point, you're given the gradient, you can just plug it into this equation as we have discussed. And we're done with this topic.